everyone. My name is Danilo Oliveira. I am from UFPE, Brazil, and I will present this work that is NFS-RODS, a tool for accessing iRODS via the NFS Protocol. This is our agenda. We start talking about iRODS clients and the NFS Protocol. Then we show how to integrate iRODS and NFS. We show how to download and install our source code, make some conclusions, and we finish with a live demonstration. Well, we know that iRODS is a powerful data grid middleware, and we know how much it has to offer. But to increase the usefulness of iRODS, we developers must provide convenient applications that address the user's need. We have some, this is an incomplete list. We have some clients available, some based in the C API, others based in the Jargon API. And most of them provide some kind of graphical interface. And each of them has its strong and weak points, and I presume that none of them will be suitable for every situation. For instance, consider the following problem. What if a system administrator wants to provide access to iRODS to a set of 100 Linux workstations, and this access is transparent for the user, and without having to install the client application in every workstation, or even the iRODS runtime? Is that possible? This is the question that we hope to solve with our project. By using the NFS protocol, we create a layer between clients and iRODS that is transparent for the clients, because they will rely on the mount system command to mount folders. They will operate in that folders, and they will change the associated iRODS collection. This project was created on top of UNFS, what means that it runs in the user space. And the NFS is a system protocol that defines a distributed file system. The objective of NFS is to provide transparent access for clients. Clients will operate in remote folders as local ones. This is the goal of NFS. Here is some technical details. It could run in UDP or TCP as transport layer. It uses the RPC protocol to define the callback functions in the server, and uses the XDR protocol to define the format of response and requests. And it's a stateless server. Well, in some sense, we can view iRODS and NFS as similar things. Both provide remote storage for users. They provide the same operations. For instance, download files, upload files, listing the directories. But they are completely different concepts. iRODS is much more than this. Therefore, our main challenge in this project was how to translate NFS calls from the clients to the corresponding iRODS API calls. There is no perfect matching, how we will see. For instance, this is the complete list of applications of server procedures in RPC protocol. Those are defined in the RFC of NFS version 3. And we have two columns. The functions in blue, we have implemented all of them. And those in red, they are not possible to implement because there is no such matching between NFS and iRODS. For instance, the Silink function is not possible because, for the best of my knowledge, iRODS do not provide symbolic links. But they were not essential for a functional basic server. Likewise, the attributes of files in Unix world and the iRODS attributes for objects, were not fully compatible. There's some difference. For instance, the time-related attributes, we have two in iRODS, the create time and modify time. And in our installation, I don't know if it's general, but we see that they provide the same value. And our solution was simply to replicate the create time to A time, M time, and C time in the response of NFS. And likewise, the file permissions, they were different, and we adopt this table to perform translation between Unix permissions and iRODS permissions. And this is our architecture. We have three components besides the client. We have an optional authentication server that uses PEN. We have the NFS-RODS server that translates the calls from clients. And we have the iRODS backends. And this is the flow of communication. First, the client will log in the system using his credentials that are stored in the authentication server. After that, he will map the remote folder in NFS world and perform some operations in the terminal or the system. And these calls will be translated by NFS-RODS to corresponding iRODS calls. And the iRODS will receive the calls from iRODS API to change the respective collection. And it uses the user credentials to guarantee access authorization for private folders. Each user will see only his folder. But if we do not want to configure the whole authorization scheme, they just can use the public folder. All folders stored in the /home/public folders are completely free. We can access these folders without having to authenticate in the server. We can bypass the authorization. Sorry. We can bypass the authorization scheme by mounting folders stored in the public folder. This is a diagram of the main source files of our project. There is a lot of files. They are the most important. The daemon.c contains the main function that starts a daemon. The NFS.c will implement the callback functions, and we separate the iRODS API calls in, we encapsulate them in the RODS API.c that maps that provides some high-level functions because the iRODS API is a bit low level, and we have a user package for convenience. And this is how we download and install NFS-RODS. We can clone the project. We have a make file that compiles everything, it's okay. And to run, we must install RPC bind because NFS uses RPC, and then start NFS-RODS binary without the ampersand because it's starting then. This is our project page. We can see the documentation and the source code in this link. And additionally, we provide a .pro file if someone like me do not like VI or Emacs. We prefer some fancy IDE. And our conclusions is that NFS-RODS allow administrators and users that are familiar with NFS to interact with iRODS. And another conclusion is that because they were not fully compatible, we had to make some decisions because things are not perfect. But we are able to deliver a functional basic NFS server for clients. And then we will perform a live demonstration. We have 4 virtual machines. This is the NFS server. We have an iRODS and plus authentication server in the same machine. And we have 2 clients. Let's see the NFS-RODS server. In the NFS-RODS server, we configure the access, we control the access with the traditional export file. We have 2 folders exported, and besides the traditional meaning of export file, it also defines if authorization will be used. If a line ends with public, no authorization. If it does not end with public, we have to authenticate in the server. The server is already running, and let's perform some operations. We mount a public folder. Let's move to the directory. Let's list the contents. And let's see in the iRODS the same list of objects and folders. Let's create a file. The file is here, but let's see the iRODS. The file was created. We can remove also. The file is gone. We can create folders. And the folder will be created in iRODS. Here. And let's create a file with contents using a text editor. Let's see in the iRODS I get iOS, I get new file, everything's okay. And the final test is to show how to share file between users with the public collection. We will mount in the another client, the same folder. adding file. Finally, let's see the previous slide. And with a cat. Okay, this is worth it. And that is all we have to show for you. Now, any questions?
Do you have any performance numbers at all for anything?
We have.
Yeah.
In the internal meetings, we show some benchmarks. If you are interested, we can provide it.
I was just wondering if you had anything to tell anybody. I think I've seen some of them. I just didn't know if that was shareable.
In general, this performance is about the same as running the server itself. When they were doing some work here, but we weren't able to do it in time to get rid of this at full scale. They tried to look for some amount of degradation in it, and obviously because it's running a separate NFS server, there's some impact due to that. But their environment is totally virtual, so they did comparisons between the standard NFS server and the one that they modified to do this work with, and they seem to be matching pretty well for files of 10 out to a gigabyte size and 2 to 5 users. So, sorry, no, I didn't mean to take that over, but you did show us a slide.
Great job. This is useful, and I think it's very important to the iRODS community.
Thank you.
I just wanted to say that. I am curious, like, what is the consortium model going to be when you have something that looks to be like so interesting in terms of having like a coherent stack that includes things that are happening in the community? One of the issues has always been you have lots of things happening anywhere, but how do we get a one-stop shop or some kind of incubator model where things can move into the consortium ecosystem, if you will? Is there
By moving into the ecosystem, you mean move in support by the consortium?
like
From the community, or?
Well, it doesn't. There can be levels of support. One could almost be like, here's an acknowledgement of, here's this capability. It's NFS. It's like we're not directly supporting it.
That's the iRODS hub.
That's the iRODS hub.
That's the hub, yeah, which will have it all posted on.
Okay.
I mean, the second layer there is to get things into some sort of continuous integration.
Yes.
And we have a desire to write a couple blog posts on how to get things into Travis CI using iRODS, and then from there it's a question of working through the technology working group as to what the consortium as a whole, its membership decides they want to support directly as a critical piece of infrastructure. But those are sort of the layers of I see progressing.
But it's awesome.
Yes. So this looks like a real file system, and effectively the directory tree of iRODS is like Postgres. So if I type ls, am I reading the Postgres database to read the directory structure of iRODS? How am I reading? How am I looking at the directory?
Dave, what they're doing is that they're mapping the DLS you're doing as an NFS call to iRODS.
Okay.
And iRODS is returning that.
It's returning. Okay, got it. Thank you.
If you look at the iREG,
We all got confused multiple times on that very point, trust me.
I was trying to figure out what the change.
Yeah, and when we're going through this, you might, as Danilo was talking, one of the problems that had to be addressed here the hard way was trying to figure out how to keep track of
who's what in the authentication model, given that NFS doesn't really support this kind of authentication scheme.
Right.
So some of this is perverted. Okay.
If you look at the iREG command, you'll see how iRODS supports symbolic links using microservice objects. So you can register an item from another collection or even another site as a file in that collection.
Well, it can be implemented in the future.
Just a question regarding metadata. It doesn't support it currently, correct? So if you are interacting with a resource that does have metadata and you alter the resource, what happens to the existing metadata? Nothing,
You
it's just left
will
in
not
place?
see any method.
But nothing gets altered on server side?
Do you have a way to set access controls or access permissions for other people? Change log?
We can see the permission with ls/a, and we can change with chmod. We use this table to match things.
Very nice work. I congratulate you with it. I was just wondering, how does this work with if you have multiple resource servers? Can you indicate by uploading a file through NFS on which iRODS resource it needs to be stored?
They will use only one resource. It uses a configuration file, JSON file. You set the resource. No, this one.
Yeah, because you now make the NFS export on a particular resource server, right? So I was then wondering, well, can you also, if I upload something into iRODS using just an iPut or something, I can indicate on which physical resource I want to store it on.
Oh, yeah.
Can you do that with
No.
NFS?
Because of the way the server works, the association is on the Unix server is running on to the mount point.
Yeah.
You can, well, whatever, you can.
But then
you
using
do that if
policies
you
or
want to,
rules,
but
it could maybe replicate once something is in and then replicate to another resource.
you can probably do it, but the risk you're running to do that is, remember, this again in NFS-P3, so you run into the problem, you get a race condition when you do that, so the final copy you get will depend upon which one finishes first. So that's one of the, we would not recommend. This has nothing to do with your implementation, this is sold NFS stuff. I would never recommend you do that if you want to have a reliable environment.
Okay.
Sorry, I thought in the zone. We configured the zone in this.
You showed a diagram with an authentication server, and if I saw it correctly, it had communication lines between the NFS client and NFS-RODS software you wrote, and iRODS. Can you explain a little bit more about how the authentication works using this authentication server?
Well, this is a normal, right? You will log in the system with your credentials that are stored, for instance, in cameras or update. And when you mount the folder, each operation will send the credentials. The credentials will be looked up in the server to guarantee private access.
So does the authentication server store an iRODS password? Or does iRODS have a separate?
So what the NFS server is doing is running as a RODS admin, and it's using the proxy behavior of iRODS. So it's actually acting on behalf of the various users, which is why we need a central authority for authentication from both the iRODS side as well as the basically the NFS side.
Okay.
Just account authentication in this case.
Yeah. And so it can be Active Directory, Progress, LDAP, whatever you want.
Okay.